Welcome to Theory of Computation class. In today's class, I'm going to explain the concept of pumping lemma. It is a technique which is used for finding a given language is regular or not. So it contains a theorem and few problems will be discussed in the following session. So prove languages not to be regular. So how can it be formed? A powerful technique which is used to prove certain languages are regular or not. So those techniques are called as pumping lemma. Otherwise, it is called as a technique used for proving a language is not regular. So where we apply this pumping lemma concept means for finding a language is regular or not, or you can automatically check the finite automata whether the automata contains a finite or infinite set in it. So in this way also we can able to check it out. So what the theorem says means, let L be a regular language, then there exists a constant, which means that it contains some strings in it. Set of strings are framed with a language. So we are taking only few strings in it such that Z is a set of string, and you can frame that string using this following 5 steps. First step 1 is Z equal to UVW, where UVW are substrings of Z. Then N means the number of states. Here we are considering it is constant. So constant means constant integer values. It may be from 1 or greater than 1. So what is the second condition means mod Z, that means the length of string should be greater than or equal to your given n value. So this will be assumption. Then mod UV, that means that if you combine two substring U and V, the length of UV should be less than or equal to n. So this should also be true. Like that only you should take n value. And fourth one is mod V value that should be greater than or equal to 1. So these first four conditions should be satisfied. If first four conditions will be satisfied, then you should prove the fifth condition. The fifth condition is you are framing the first condition as Z equal to UVW. Like that, you should prove it for UV power IW, but that UV power IW does not available in a particular language L, because this is a UVW or substrings of Z. So if you try to form UV power IW, that should not be satisfied by L. That means this string should be a wrong string. So in this way only you should prove it. So let us take the first example. Prove that L is equal to A power n, B power n, where n greater than or equal to 1. So this is the given statement. You should prove that it is not regular. First you should write a correct value of L. So if I am substituting n is equal to 1, the string is AB. If n is 2, it is A squared B squared. Let us write as AA double B. Then n is equal to 3 means A cube B cube, which will be written as AAA triple B. Like that, the correct strings are there. Then what is your first step? Z should be equal to UVW, and the second condition is mod Z that should be greater than or equal to n. Okay, what is your third condition? Mod UV that should be less than or is equal to n. Your fourth condition is mod V value greater than or equal to 1. This should also be satisfied. So how can we frame it? If I am taking first symbol, only two symbols are there at the first string. So you cannot make three substrings. So let us take the second one. It contains AA double B. So either you can take it as U as first A, V as first B, and B as W. Okay, so consider how can you frame AA double B? If n is equal to 2, you can able to form it as AA double B. So I am writing as consider n is equal to W. So your L value is A squared B squared. So Z equal to double A double B. So from this thing I am taken as U equal to A, V equal to A, W equal to BB. So these are all satisfied. And the second condition is mod Z greater than or equal to 1. What is the length of the string? It is 4. What is your n value? I am taking it as 2. 4 greater than or equal to 2? Yes, it is true. What is your mod v value? It is 2. Less than or equal to n value is 2. 2 less than or equal to 2, it is also true. Then fourth condition is mod v, it is 1. 1 greater than or equal to 1, it is also true. Then we should prove it for z equal to u v power I w. So let us take u value. U is single a. V is also single a. W is double b. So what is I? I is an integer. So here I consider I value is also 2. So if I am taking 2, a squared. So what is it? Triple a double b. So this triple A double B, check whether this string is available in the given L. No, it's not available. So this L contains only equal number of A's and B's, but I have only retrieved triple A double B which is not satisfied in L. Therefore, it is proved that not regular. Okay. Then the second problem. Here L is equal to 0 power n squared. So if I am taking n is equal to 2, substitute it 0 power 2 squared. So 4 zeros. So Z equal to UVW. So here 4 zeros are available. So last 2 zeros will be considered as W. Okay. So this is the first condition. Second condition, mod Z value greater than or equal to n. So the length is 4 greater than or equal to 2. It is also true. Your third step is mod UV value that is less than or equal to n. So 2 less than or equal to 2. It is also true. Fourth condition, mod V value greater than or equal to 1. So 1 greater than or equal to 1. It is also true. Then Z equal to U V power I W. So here I am taking I is equal to 2 means U value is single 0, V is single 0, I value is 2, W is double 0. So it's 0 power 5. N squared means what? 0 power n squared means if you substituting n is equal to 1, 1 0. N is equal to 2 means 4 0. N is equal to 3 means 9 0. N is equal to 4 means 16 0. So which is not available in L. So therefore the given language is true. Here you take P is prime value. So instead of N there may be the possibility of giving other variables. Here instead of N P is given, but you should take prime number. P as prime number, so you write the list of prime numbers. So 2, 3, 5, 7, 11, 13 like that. So using that only you should frame the value. So either 0 squared, 0 cube, 0 power 5, 0 power 7, 0 power 11, 0 power 13 like that. This should be the correct strings available in a given language L. So like that only you should take Z value. You should have UVW at least 3 values. So consider I am taking n is equal to 5. That means n means P value. P is equal to 5. So 5 zeros are there. I consider U, V, W as 3 0. This is first. Second condition, mod Z greater than or equal to n. Mod Z is 5. I am taking P as 5. So 5 greater than or equal to 5. It is true. Mod UV less than or equal to n. Length is 2. Here P value is 5. It is also true. Mod V value greater than or equal to 1. Yes, 1 greater than or equal to 1. What is your fifth condition? Z equal to U V power I W. So if I am taking I is equal to 2, it will be written as single 0 squared and then 3 0. So what is it? It is 0 power 6, which is not a prime number. So the given language is not regular by using the pumping lemma technique. And here instead of 0 they are giving a power n something. So if I am substitute n is equal to 2, the correct string is a squared b a squared. So you expand it. So here I am taking z double a b double a. So first letter U, second letter V, the remaining 3 letters will be considered as W. So you write the rules Z equal to UVW. I am framing it. Mod Z value that should be greater than or equal to N. It's also the length is 5. I am taking N is equal to 2. It's true. Mod UV value less than or is equal to N. So it's 2 less than or equal to 2 true. Mod V value greater than or equal to 1. It's also true. Z is equal to U V power I W. Here I am taking I is equal to 2. It's not only necessary to take I value as 2. You can either take it as 3 or 4 like that. For simplified purpose only I am taking I is equal to 2. Okay. So here U value is single A. V value is single A. I value is 2. It is B double A, which is nothing but A cube B double A. Here you consider the left side of B contains number of A's, the right side of B contains some number of A's, but those A's are equal. Here which is not equal, so it is not satisfied. Like that, you can also do this exercise by your own way. Okay. So these are all the homework problem. You do it by yourself. And here there may be the possibility of giving like this WWR. What is the meaning of WR? It is string reverse. So they are giving the string format. So first you expand it. Your W is A power n B power n. WR means B power n A power n. So this is the generalized form of the given value. So here I am taking n is greater than or equal to 1. So first you write that expanded form, then you substitute the value. So here I am substituting n value as 2. So a squared b squared a squared, which is double a double b double b double a. Here it is considered as z. Then you list out the remaining values. Here W is considered as A power n. So the language, in the language 2 W is there. So A power n, B power n, again A power n, B power n. This is the value. Okay. You try by yourself. Thank you.